Probability in data science. Probability helps us understand how likely an event is to happen. It forms the foundation for predictive modeling, machine learning, and statistical inference. Examples are, if a spam filter says there is 80% chance that email is spam, that 80% comes from probability. We don't know the outcome of a particular situation until it happens. Some terminologies in probability: experiment are uncertain situation which could have multiple outcomes. Whether it rains on a daily basis is an experiment. Tossing a coin, it is a experiment. Outcome is a result of single trial. That is, if it rains today, the outcome of today's trial from the experiment is it rained. Tossing the coin, outcome of tossing a coin is head or tail. Event is one or more outcome from the experiment. It rained is one of the possible event for this experiment. Suppose we toss the coin three times. Toss the coin three times. Toss the coin three times. Head, tail, tail. These are the outcomes in each occurrence. So sometimes we may add the event odd events. Odd events means odd events are H and T. That is event. Outcome means it is H and T, tail and head only. Result of the trial. Trial means experiment. Probability is the measure of how equally likely an event is. So it is 60% chance that it will rain tomorrow. The probability of the outcome it rained for tomorrow is 0.6. Key concepts in probability. Rule 1, probability ranges from 0 to 1. That is, 0 means event won't happen, 1 means event will happen. Total probability of all possible outcome is 1. That is, for a coin toss, probability of head plus probability of tail is 1. Addition rule is also there. Probability of A or B is probability of A plus probability of B minus probability of P and B. Multiplication rule. If A and B are independent, then probability of A and B is probability of A into probability of B. Random variables. Random variable is a variable that represents the outcome of the random experiment. Its value is not fixed. It assigns a numerical values to the outcome of random process. For example, when you toss a coin three times, the number of head you get in is a random variable. It could be 0, 1, 2 or 3. Three times you could toss the coin. So first time there will be no head. There may be one head. There may be two head. All the for all chances we got head. It is 3. So type of random variable 2, discrete and continuous values. Discrete random variable. A random variable is discrete if it is finite or count. Discrete means it will be always finite or countable. You can list all possible outcomes. Values are separated or distinct and it often results from counting, and each possible values have some specific probability. Number of heads in 3 coin toss is 0, 1, 2, 3. Then what about continuous variable? It can take any value within given range. Possibly it is infinite. Continuous means it will be infinite and it is not countable and it can be measured. The probability for a specific single value is 0. Instead, we calculate the probability for an interval. For example, height of student 150.5 centimeter, 160.75 centimeter, etc. Then about distributions. These distributions are important. Binomial distribution. It is the probability distribution used to find the likelihood of getting a certain number of success. Number of success is fixed. If the number of success is fixed, you can use binomial distribution. And each experiment has two outcomes. So number is fixed, number of success fixed, and two outcomes, then you can use binomial. So for binomial, probability is like this: n factorial divided by x factorial into n minus x factorial into p raised to x into 1 minus p a whole raised to n minus p, where n is the number of trials, p is n is the number of trials, r is number of success, p is probability of success. Success means getting heads. Failure means getting tails. That is, we are considering tossing coin here. So when to use binomial distribution? Fixed number of trials, two possible outcomes, trials are independent, and same probability of success in each trial. In this case, we can use binomial distribution. One example: a fair coin is tossed 2 times. What is the probability of getting head? Number of toss 2. X equal to, in first case, number of head may be 0. Second case, number of head may be 1. Again 2. Maybe 0, 1 or 2. Probability of head is 0.5. This is for success. For failure, that is what is P plus Q. Total probability is 1. P means success and Q means failure. So what is Q? Q equal to 1 minus P. That is failure. To calculate the probability of failure, 1 minus P. P is already 0.5. So Q is also 1 minus 0.5. That is equal to 0.5. So we are considering the cases. First case means x equal to 0. X equal to 0. There is no head. No head means you just substitute this. Our equation is this is our equation: n factorial divided by x factorial into n minus x factorial p raised n raised to x, p raised to x into q raised to n minus x. 1 minus p means q. N factorial divided by n minus x factorial into p raised to x, q raised to n minus x. So n is 2 divided by x is 0 into p, that is 0.5 raised to x, q 0.5 raised to n minus x, that is 2. So simplifying, you will get 0.25. X equal to 1. Similarly, you substitute and you will get 0.5. X equal to 2, you will get 0.25. So x equal to 0 means probability is 0.25. Outcome is tail, tail. Probability of 1 means 0.5. That is, these are the cases. So you can plot the bar chart also. This is the chart. Number of heads are 0, 1, 2, and the probabilities. So probability mass function is it gives the probability of exactly k success. Then next distribution is Poisson distribution. It is used to model the number of times an event happens in the fixed interval of time. So you can use Poisson distribution to predict or explain the number of events occurring within a given interval of time or space. It has one parameter lambda and it is the mean of number of values. It is a discrete probability distribution. Discrete means it is countable. Discrete, it is number of times an event occurs. Discrete outcome, that is number of events and number of times an event occurs, that is k. So equation is event happen randomly and it does not affect each other. How many events happen in a certain interval of space or time? This is called lambda. So this is the probability distribution equation. So x is the number of outcome, lambda is the average number of occurrence in the interval, E is the Euler number, that is 2.7818 x factorial. So one example, 3 emails per hour on average, lambda equal to 3. Average value, that is lambda equal to 3. What is the probability of receiving exactly 2 emails in an hour? So 0th hour, this is given, 0th hour x equal to x. So our equation is x raised lambda raised to x into e raised to minus lambda by x lambda. Lambda raised to x, e raised to minus lambda divided by x factorial. So we know lambda value, lambda equal to 3. 3 raised to x is 0, 0. E raised to minus 3 divided by 0 factorial. You will get this one. Then 3 raised to 1, e raised to minus 1 divided by e raised to minus 3, lambda is 3 divided by 1 factorial. You will get this. Similarly substitute x values in this equation. You will get these two values. So finally for 3 emails per hour, you will get 0.224. So what is the difference between binomial distribution and Poisson distribution? Number of success is fixed. Number of events is fixed. Number of success, here it is events. Fixed number of trials are there. Here there is no fixed number. 2 outcomes. Here non-negative integer. Constant success probability for each trial. Constant average rate for each event. Here example, tossing a coin 10 times. Counting phone call received. When it is used, trials are limited and discrete. Here events happen randomly over time or space. Then next is uniform distribution. A probability distribution where each outcome within the specified range has equal probability of occurring. That is rectangular distribution. Two types of uniform distributions are there: equally likely outcome and continuous or discrete. Every possible outcome within the range has same probability of happening is known as equally likely outcome. Continuous or discrete means uniform distribution can be continuous, means it falls within a range. Discrete means it is countable or distinct. Parameters. Continuous uniform distributions are defined by two parameters A and B, that is minimum and maximum. It is denoted by UAB. So rolling a fair 6-sided die, it is 1, 2, 3, 4, 5, 6. 6 values are there, each has equal chance. So probability is 1 by 6. So you will get a bar chart like this, probability mass function. So discrete uniform distribution applies to finite and countable outcomes. Continuous uniform distribution means values within the range are equally likely, but since there are infinitely many values, you can use PDF. So PMF is equation is 1 by n. PDF is f of x equal to 1 by b minus a for all a less than or equal to x less than or equal to b. Normal distribution. It represents large number of random values. Normal distribution is a continuous probability distribution that is symmetric about the mean. Because the data are near to the mean are more frequent in occurrence than data far from the mean. That is, this one is normal distribution will be represented like this. This is mean. It will be concentrated more towards the mean.